Good day, ma'am. I am Matanghilo Gigakot from BSEE2B. So, for the assessment, question number 1. The force applied at the handle of the lever causes the lever to rotate clockwise about pin B through an angle 2 degree. Determine the average normal strain in each wire. The wires are unstretched when the lever is in the horizontal position. So, given tayo dito ng diagram. So, first, para ma-visualize natin yung mga unknowns parameters, draw a FBD or a free body diagram. So, for I1 is equals to 200 mm, I2 200 mm, I3 300 mm, I4 200 mm, I5 300 mm, and I6 300 mm. So, applying formula, theta is equals to 2 degree or the quantity of pi all over 180 times 2 degree rad. So, getting the average strain at AH. So, summing forces at AH is equals to delta I1 all over I1 is equals to I2 times pi all over 180 all over I1. So, times 2 is equals to 200 times pi all over 180 times 2 all over 200. So, our AH is equals to 0.0349. So, next, delta I1 elongate to wire AH. Delta I1 is equals to AB times theta is equals to I2 times pi all over 180 times 2. So, for delta 5 elongate to wire CG, CG delta 5 is equals to CB times theta is equals to I3 times pi all over 180 times 2. For delta I6 elongate to wire DF, delta I6 dB times pi is equals to the quantity of I3 plus I4 times pi all over 180 times 2. So, for getting summing forces along CG is equals to delta I5 all over I5 is equals to I3 pi all over 180 times 2 all over 1 over 5, I5 rather, is equals to 300 times pi all over 180 times 2 all over 300. So, our CG is equals to 0.0349. The same as our AH. So, getting the average strain of DF, summation of forces along DF is equals to delta I6 all over I6 is equals to the quantity of I3 plus I4 times pi all over 180 times 2 all over I6 is equals to 300, which is our I3 plus 200 our I4 times pi all over 180 times 2 all over 300, which is our I6. So, getting DF, our DF is equals to 0.0582. So, for question number 2, the square deforms into the position shown by the dashed line. Determine the shear strain at each of its corner A, B, C, and D relative to the X and Y axis. Side DB remains horizontal. So, we have another diagram here as para ma-visualize natin yung mga announced parameters, draw a free body diagram. So, the quantity of gamma, x and y, A is equals to change in angle at A is equals to 90. The quantity of 90 degree minus 91.5 degree is equals to negative 1.5 degree. Negative 1.5 degree times pi all over 180 rad. Makukuha natin sagot ay negative 0.0262 rad. So for our gamma x and y, d change in angle at d, the quantity of 90 minus 88.5 degree is equals to 1.5 degree. 1.5 times pi all over 180 rad. So convert into rad, magiging answer ay 0.0262 rad. So for question number 3, the rigid beam supports the load of 60 kN. Determine the displacement at B. Take E is equals to 60 gigapascal and A sa BC is equals to 2, the quantity of 10 raised to negative 3 meters squared. So given tayo ng diagram, so draw a free body diagram for easy for us to visualize the unknown parameters. So dito magsasum tayo ng forces along MA side A. So summing forces positive counterclockwise, summing forces along MA is equals to 0. RB times 6 is equals to 60 times 2. RB is equals to 20 kilonewton. RB is equals to 20 kilonewton. Delta L, getting delta L is equals to RBL. We have a formula RBL all over AE is equals to 20 times 10 raised to 3 x raised to 3 or times 3 all over 2.4 times 10 raised to 3 raised to negative 3 rather times 70 times 10 raised to 9. So our delta L is equals to 0.357 millimeter. So for question number 4, the plug has a diameter of 30 millimeter and fits within a rigid sleeve having an inner diameter of 32 millimeter. Both the plug and the sleeve are 50 millimeter long. Determine the axial pressure P that must be applied to the top plug to cause it to contact the sides of the sleeve. Also, how far must the plug be compressed downwards in order to do this. The plug is made from a materials for which E is equals to 5 megapascal, V is equals to 0.45. So given RL, the number of plug and sleeve 50 millimeter, D, number of plug is equals to 30 millimeter, the inner diameter of the sleeve, which is our D, is equals to 30 millimeter, the modulus of elasticity, RE, is equals to MPa or megapascal, the Poisson ratio, the nu is equals to 0.45. So summing forces, the lateral is equals to Di minus D all over D. Applying forces to formula, 32 minus 30 all over 30 is equals to 0.0667. So summing forces summing forces longitudinal is equals to 0.0667 all over 0.45 na ating Poisson ratio is equals to negative 0.1481. So the shear axial is equals to EX longitudinal RP is equals to 5 times 10 raised to 6 times 0. The quantity of 0.1481. The result will be 741 kilopascal. So for the last question, question number 5. The 10 mm diameter steel bolts is surrounded by the bronze sleeve. The outer diameter of the sleeve is 20 mm and its inner diameter is 10 mm. If the yield stress for the steel is shear Y sub ST is equals to 640 megapascal, and for the bronze shear Y sub BR is equals to 520 megapascal. To determine the magnitude of the largest elastic load P that can be applied to the assembly, E sub ST is equals to 200 gigapascal. E sub BR is equals to 100 gigapascal. So our AST is equals to pi all over 4 d squared. So that's our formula, applying forces to pi all over 4 d squared. So pi all over 4 times the quantity of 10 squared is equals to 78.54 millimeter squared. So ABR is equals to pi all over 4 the quantity of d squared minus di squared. So applying forces to that formula, pi all over 4 times the quantity of 20 squared minus 10 squared is equals to 235.62 millimeter squared. So with that, applying forces longitudinal, so summing forces going to the right, summing sign convention, positive going to the right, summing forces along f of x is equals to 0. PBR plus PST is equals to 0. So PST plus PBR is equals to P. So SBR is equals to S sub ST PBR L all over ABR EBR is equals to PSTL all over AST EST. So PBR all over ABR EBR is equals to PST all over AST minus AST. So that's a conversion of the formula. So applying to that, ABR is equals to PBR is equals to ABR times the shear of Y BR. So is equals to 235.62 times 520 is equals to 122.522 kilonewton. So our PST, applying to that given formula, I'll get sa nakuha nating formula, 78.54 times 200 times 122.522 all over 235.62 times 100 is equals to our PST 81.681 kilonewton. So PST is equals to the quantity of shear Y S sub ST AST. So 640 times 78.54 is equals to 50.265 kilonewton. So PBR all over 235.62 times 100 is equals to 50.265 all over 78.54 times 200 is equals to 73.398 kilonewton. So getting P is equals to 50.265 plus 75.398 is equals to RP will be 125.663 kilonewton. So getting P minimum is equals to 122.522 plus 81.681. The answer will be 204.203. So, ito na yung P minimum of 225.633.204.203 kilonewton. So, our final P is equals to 125.633 kilonewton.